Hey everyone, I believe I'm audible. So yeah, let me know if you guys can hear me well, and also let me know how did the contest go. Like, how were the problems? Were you able to solve all of them, or you are not able to solve one of some of them? Do let me know about that. How did the contest go? For let me know if you guys can hear me well. How did the contest go and about these things? How did the contest go? यार चैट पे लिख दो थोड़ा. Let me quickly set up this whiteboard background. बैक कर देते हैं. Yeah, how did the contest? How was the contest? How did it go? And were you able to solve all the problems you are not able to solve? What's the status there? Last one had n cubed TC. Yes, yes. So that had to have n cube, right? Cool. Anyways, let's actually start with let's start discussing the problem without wasting a lot of time. So the first problem is pretty simple. So the problem statement is you are given three integers: a denoting the first term of an arithmetic sequence, c denoting the common difference of the arithmetic sequence, and an integer b. You have to tell whether b exists in the arithmetic sequence or not, right? So okay, so you have three integers, right? A, C. A is the first term, right? A is the first term. C is the common difference. So C is the common difference, and you have to tell whether B exists in the arithmetic sequence or not. Okay, Milind. Let's understand. You will like. I hope that this session will actually help you understand how to solve those problems, right? So let's understand. So for the first one, I'm pretty sure that you've got the logic, but yes, there was many corner cases. So let's actually understand what happens. So in general, like without tackling any corner case, what is the formula of an arithmetic sequence? A formula of an arithmetic sequence or an arithmetic progression is a plus c, that is the common difference, into some number n equals to b. This is what we want, right? A plus common difference into n should be equals to b. So that means that b minus a, it should be divisible by c. It should be divisible by c because n should be an integer, right? N should be an integer. So if you just take b minus a, it is equals to c into n. That means b minus a should be divisible by c when n is an integer. So this is the condition for it to be an arithmetic sequence. However, there are a lot of corner cases here. What are they? First, let's understand, right? So let's say we start off at 4, right? A is 4, b is minus 12, and let's say c common difference is 4. So can you reach minus 12 using 4 and a common difference 4? So what will be the AP that will be generated? 4, 8, 12, 16. So it's impossible for you to reach minus 12, right? But if you see b minus a, that is minus 12 minus 4, that is minus 16. Minus 16 is indeed divisible by 4, right? So that is one of the corner cases. Another corresponding, like another similar corner case will be if you have something like, let's say, minus 4 and you want 12 and the common difference is minus 4. In this case also it is not possible because minus 4, minus 8, minus 12, minus 16, this is the arithmetic progression that is generated. So you definitely cannot reach 12, right? You definitely cannot reach 12. So these two are corner cases. Other than that, what can be other cases? Like let's say common difference is 0, right? Common difference is 0. C equals to 0. In that case, what will happen? if you start off at A and B, like let's say you start off at 4 and B is equals to 8, you can never reach 8 because you have a common difference of 0. So it will be 4 4 4 like this, the sequence. So only when B is 4 in this case it will be a valid, otherwise it will be invalid, like you cannot reach. So that's another one. Other than that, in most cases B minus A modulo C should be divisible, right? Like let's say common difference, you are start at 4, you want to go to minus 12 and common difference is minus 4, right? So you can actually go to minus 12 in this case. 4 0 minus 4 minus 8 minus 12, so you can actually reach minus 12, right? So in every other case it will be B minus A should be divisible by C, right? B minus A should be divisible by C. I hope that I'm not missing any case, but we can figure out like once we go ahead. So let's try to write this. So the first condition is if C equals to 0, right? If C equals to 0, in that case, what can be B? If B is equals to A, right? Then we'll return 1, that it is possible, otherwise we'll return 0, it is not possible. That is the first one. Second is if B is less than A. If B is less than A and C is greater than 0, it means that the target that you want to reach is less than the starting element, but you have a positive common difference. So what is common difference? It will be added to your starting element, so the corresponding terms will be greater. So if B is less than A and C is greater than 0, in this case you have to return 0 because it is not possible to reach. Similarly, if B is greater than A, if B is greater than A and C is less than 0, that means what? What is the next term? A minus C, like A plus C is less than 0, that is minus. So A minus 2, A minus 4, like that it will go. So it will be going to lesser terms, but your target is greater. So it can never reach a greater element, right? So in that case also it is return 0. Otherwise, if we'll go for the normal condition, check that if B minus A modulo C is equals to 0, in that case we'll return 1, otherwise we'll return 0. Okay, so let's run this, compile and run. So we get 1 here, that's true. So let's try to submit. I'm hoping that I didn't miss any case, but there can be some others as well. Okay, it's done. So did you understand the logic? Like how did we solve this? So these are the cases. Like first is, in every other case it will be like B minus A modulo C should be equals to 0, right? Because you can actually reach if it is a divisible. But these are the cases like when B is less than A but you have a common positive common difference, so your terms should be greater, not lesser. Similarly, if B is greater than A and you have a negative common difference, so your term should be lesser, not greater, right? Similarly, here C is 0, that means only like B is A, only then it is possible, otherwise it is not possible. So these are the cases that we had to handle. Is the logic clear? Like, is this part clear why B minus A should be divisible by C? I believe that was the trick. Other than that, every other thing is just a corner case that you had to tackle. So is this clear with everyone? How to solve this? Milind, is this clear with you? Is this clear? Let me know in the chat. Okay. That's fine. That's totally fine. Like I also had 5 wrong submissions, right? Or 4 wrong submissions. So it's tricky. Like you have to think about the corner cases, but again, like that's fine. Let's solve this one, right? Okay. Second problem, it's actually pretty simple. So it's event swap, right? You are given an array A and your task is to generate another array B by applying only one operation any number of times, right? In one operation, you can swap AI and AI plus 1. like two consecutive elements, but only if ai plus 1 is even. Note that B will be lexicographically largest among all possible arrays that can be generated from array A after applying the moves any number of times, right? So basically what it tells is that you are given an array A and you have to apply swapping, right? You have to swap two adjacent elements. You can swap them any number of times, right? You can swap them any number of times. You have to generate the largest lexicographically possible array. There is one catch, however, that ai plus 1 should be even. Only then you can perform a swap, otherwise you cannot perform a swap, right? So for example, let's take this example 135. In this case, if you see, we can swap 1 3, we can swap 3 5, right? So first we'll swap 1 3, it will become 3 1 5. After that we'll swap 1 5, it will become 3 3 5 1. Then we'll swap 3 and 5 again, it will become 5 3 1. So the largest array that we can generate is 5 3 1, right? Similarly 1 3 4 2, let's actually talk about 1 3 4 2 a bit, right? Let's talk about that. Okay, is there anyone who has solved this problem? Anyone who has solved this problem? And how did you solve this problem? So we have 1 3 4 2. See, can we swap 1 3? Yes, we can swap. Can we swap 3 4? No, we cannot swap, because 3 plus 4 is odd, it is not even, so we cannot swap. 4 2, can we swap? Yes, we can swap. So let's just swap 1 3 for now. So 3 1 4 2, right? And can we swap 1 4 now? We cannot swap 1 4, right? Can we swap 4 2? We can, but there's no point, it will give a like smaller one, right? So this is the largest possible array that we can generate. Okay, so this is the largest possible array that we can generate. Selva, you have solved it. Very good. So this is a bit tricky actually, just a small trick, an observation. Yes, exactly. So the idea for this is, if you think about it very carefully, right? If you think about it very carefully, when can you swap and when you cannot swap? If you have, let's say, if you have some odd number, if you had some odd number A, and you have some B, even number, wherever it is, you have some even number B here, you can never swap these two, right? You can never swap these two. Maybe AB comes next to each other, right? Let's say B can be swapped here, swapped here, swapped here, it comes here, but you can never swap AB, right? So this actually tells us that there will be some sets of even odd continuous subarrays, right? So let's say this is a set of odd continuous subarray. Next is a even continuous subarray. Next is a odd continuous subarray. Next is a even continuous subarray. Like this continuous subarray length can be also 1, right? That means here only odd elements will be present. Let's say 1 3 5. Here only even elements will be present. 2 4 6. Here only odd elements. Let's say 5 3. Here only even elements 2 2, right? So like something like this, right? So if you see, this is the odd continuous subarray, this is the even continuous subarray, this is the odd continuous subarray, this is the even continuous subarray. Now in each of these subarrays, they can be swapped with each other. All these elements can be swapped with each other. All these elements can be swapped with each other. All these elements can be swapped. All these elements can be swapped with each other. But they cannot be swapped across each other. 2 cannot come this side, right? Or 4 cannot come this side, because the sum will always be odd. 5 plus 4 is odd, 3 plus 4 is odd, 1 plus 4 is odd. So it means that 4 can never cross this. So basically, what is the best array that we can generate? What we'll do is we'll find these continuous subarrays, right? We'll find these continuous odd subarrays, we'll find these continuous even subarrays. For each of these continuous subarrays, we can swap any element. We can swap 3 5, we can swap 1 5, we can swap 3 1. We'll find these subarrays, and then we can basically sort them in reverse order, in descending order, right? So the resultant array out of this will be 5 3 1, like the lexicographically biased array. 5 3 1. Here 6 4 2 will come in. Here 5 3 will be coming in. Here 2 2 will be coming in. So this is the largest array that we can generate. We cannot generate an array greater than this, right? Because we cannot swap across each other. We cannot bring 6 before this. We can never bring 6 before this, right? So that's why this is the largest array that we can generate. So just find the continuous odd even segments and sort them independently in reverse order. That's the entire logic. Does this make sense? Let me know if it makes sense. So let's quickly go to the implementation. I believe that will make things a bit clearer. Okay, so we have this array. Will maintain two things, I equals to 0, j equals to 0. So while j less than n, if a of I, right, if a of I and a of j are of the same parity, that is if both of them are odd or both of them are even, if a of I and 1, that will basically tell whether it's the even number or odd number, is the same parity of a, j and 1, right? If they both are of same parity, we'll go for j plus plus, that is will increase the subsequence sub array. Otherwise we have hit a wall, right? We have hit a wall, that is, let's say it was even, now it has come to a j has come to a odd element, so we basically have to sort this part. So what we have to do is we have to sort, right? Which one do we have to sort? A dot begin plus I to which point? A dot begin plus j. So remember the second element, right? The second element is one element after the after it actually has to be sorted. Like let's say you want to sort from the index 2 to 4, so this should be 5, right? And in fact that is one element after, because now j has a different parity. J is a even number. If you had I pointing to odd number, j is actually a even number. That's why we came here, right? So a of beginning plus j, and we have to reverse sort it, so we'll take a greater int here, greater int, right? We'll take a greater int here. After that is done, we have sorted a subarray. Now we want to find the next one, so we'll just make I equals to j. We'll just move I to j and we'll continue, right? In the next iteration again, a of I and a of j will be same, so their parity will be same, so it will go to j plus plus. Okay, so that's how we can do, and finally we will be left with one of them, so we can just sort the last subsequence or subarray, a dot begin plus I to a dot n, and again the comparator will be greater int for reverse sorting, right? Greater int, and we can return a after this. So this is the code. Let's run this. Inbuilt sort has n log n time complexity, by the way. You might use, but again, like there's no point, right? It's pretty straightforward. You just have to like find all the sub arrays and sort them. So it's pretty straightforward this way, so you can just definitely do like this. I'll quickly like do a dry run on this code so that you understand better, but let's submit it first. Okay, this is done, so let's actually do a dry run on this, right? Just to make sure that you understand this. So we'll take the example of 3-1. POTD, I think others are doing that. I used to do that, but I now am tackling the Amazon part, so I think others are doing that. If not, let me know, then I can actually ask them to give that to me as well. But yeah, let me know. So 1325, right? 1324 maybe, yeah. 1324, right? Let's say this is the array. So let's, yes, inbuilt, it has base time complexity like n log n, so you don't have to worry about that. And there are a lot of optimizations done as well over on top of that. So just use the inbuilt one. So okay, so we start with I equals to 0, j equals to 0, right? So I is here, j is here. Now what do we do? J less than n, yes. I, if a of I and 1 is equals to a of j and 1, what does this check? When there is an odd number, right? When there is an odd number, the least significant bit will be set for that. So if you AND with 1, it will give 1 or greater than 0. But if you have an even number, the least significant bit will be not set. So if you AND with 1, it will give a 0. It will give a 0. So basically this will check if the number is even or odd. So we are just checking that if a of I and a of j are both of same parity, that is both are even or both are odd. Is both if odd? Yes, both are odd, right? So we'll do j plus plus. So our j moves to 3. Our j moves to 3. Now in next iteration, is a of I is the if a of I and a of j both odd? Yes, it is both odd, right? So this basically checks whether both are odd or both are even, right? So both of them are odd, so we'll do j plus plus, it comes here. Now is a of I and a of j both odd? It is not odd, right? So it will go to the else part. In else part, what happens? We are sorting from a dot beginning plus I is what? I is 0 right now, and j is at index 2, so it is sorting in the range of a dot beginning, that is a of 0, a dot beginning, let's call it a of beginning to a of beginning plus j is 2, so a of beginning plus 2, a of beginning plus 2, this is sorting in this range, right? So basically these two elements will be sorted, 0 and 1, these two elements will be sorted in reverse way, right? So that's why greater int, in reverse way they will be sorted. So we can sort these two elements. So let's sort. What will be the result? 3 1, right? And let's rub these things as well. Okay, 3 1. Okay, now what do we do after that? We do I equals to j, so I also comes here. Now again we continue with the loop. Is a of I equals to a of j? Is the parity of I and j same? So both I and j are pointing to a 2, so their parity is same, so we'll do j plus plus, it will come here. Is the parity of a of I and a of j same? Is 2 and 4 both even? Yes, it is even, so we'll do j plus plus, we come to the end. So now we come outside, that's why as this part is not sorted yet, last one, so we'll again sort it, a dot beginning plus I, that is it will start at this index, and a dot end, so this will be sorted, the last part will be sorted to 4 2 4 2. So this is how we get the result. We can see submissions of others. Yes, you can see submissions of others as well. So what is the overall time complexity? Overall time complexity, let's understand that. So overall time, by the way, submissions you can see from here. There is a tab called submissions, right? And you can see all submissions, I believe. Like you can see my submissions here, and I believe all submissions. I'm not sure. Let me see. Leaderboard. Can we see from leaderboard? Or instruction coding problem. All problems. My submission. Can anyone help me how to see others submissions as well? Refresh. I'm also not sure, by the way. Please someone help me. How can we get other submissions? Anyways, let's quickly discuss the complexity. So what is happening? Like this is running, like we are just sorting like segments, right? We are just sorting segments. So although this it looks like that outside one loop we are outside a loop we are sorting, but if you consider this carefully, we are just sorting sub-arrays, and then the same element is never taken up in sorting again. So it's kind of similar to sorting the entire array, which is n log n. So the overall complexity is of n log n. Oh, okay. We cannot see all coding problems page. Okay, all coding problems, so you probably in the contest page you cannot see, probably in practice page you can actually see. Okay, got it. All right, so this is in the contest page you cannot see, right? So this is how we can solve this, right? Is this clear with everyone with respect to time complexity, with respect to solution, with respect to how is this working? Is this clear with everyone? Got it. Thanks, Silva. Silva and Hemant. Is this clear with everyone? The code. Let me know. Is the code clear with everyone? Cool. All right. So we can go to the next one, the last one. I believe everyone has solved it. Like this one had a lot of submissions. So I believe you already know how to solve this. A pretty standard problem. Like you can get this problem everywhere, right? And it's a very popular interview question as well. To like just saying this out. It's a very popular interview question. So in case you don't know it, let me just explain you once. So you are given n balloons, right? You are given n balloons, each with a number of coins associated with it. On bursting a balloon I, the number of coins gained is equal to a of I minus 1 into a of I into a of I plus 1. Also I minus 1 and I plus 1 now become adjacent, right? So find the maximum possible profit earned by bursting all the balloons. Assume that extra 1 at each boundary. Now just saying this, just to say this, whenever you have a problem, now bursting balloons, right? Bursting balloons is very, like, the problem statement is also very common, right? You might not get this problem statement, and the solution for this is an extension of matrix chain multiplication. Those who have solved it, they know that the solution isn't just extension of matrix chain multiplication. But if you have any problem, where you are given an equation like this, that the sum increases by a of I minus 1 into a of I into a of I plus 1, just blindly go for matrix chain multiplication. Just treat it as a matrix chain multiplication variant, right? Obviously read the problem statement and look at the constraint, but matrix chain multiplication will always have a n cube time complexity. So just look into the, like, if you can suit a n cube time complexity, then just blindly go for matrix chain multiplication, right? So that's the way to identify a MCM problem. Okay, so let's understand this problem statement, what it is actually telling. So let's clear the board. So let's say we have some balloons, right? We have some balloons, 2, 1, 3, 4, right? Let's say we are bursting this balloon, right? We are bursting this balloon 3. We will earn a profit of 3 into 1, the adjacent one, into the other adjacent one, 4. That is 12. And when this is burst, see, 1 and 4 are becoming adjacent, right? Now if I burst 1, I'll earn a profit of 2 into 4. Because 3 is gone, so 1 and 4 are becoming adjacent. So you have to find what is the maximum profit that you can get. But see, the way you burst actually will change your profit, right? So let's say we burst in the order 3, 1, 4, 2. This is the way we burst. In Python, how can you sort this? I believe there is inbuilt library, and I think I'm not sure if you can pass index in that, but definitely there will be some way. Okay, so 2, 1, 3, 4. Okay, 2, 1, 3 will burst in this order, right? Our order of bursting will be 3, 1, 4, 2. So let's see the profit. So first 3 is bursted. So when 3 is burst, we are bursting 3. What is the profit that we get? 3 into 4 into 1, right? Now this is gone. Now 3 is gone. Now we are bursting 1, we are bursting. So what is the profit? 2 into 1 into 4. So 2 into 1 into 4 plus 1 is gone. Then we are bursting 4. So what is the profit? 4 into 2. Because adjacent, if they're like on the corners, there is, like, just assume there is 1 here, 1 here, and you do not burst them, right? So 4 into 2 into 1. So 4 into 2 kind of. Plus finally you are bursting 2. So you get 2. 2 into 1 into 1, that is 2. So this is the total profit that you get. Let's write them down again. So 1, 2, 3, 2, 1 second, 2, how did I order them? I think 2, 1, 3, 4, something like this, right? 2, 1, 3, 4. Yes. Okay, this is one way of bursting, right? This is one way of bursting. What is the total cost? 12 plus 8 plus 8 plus 2. So 28, 30. 30 we get. Let's say we burst in a different order, right? Let's say we burst in the order 2, 4, 3, 1. In this case, first 2 is bursted, right? 2 is bursted. So the profit that we get will be what? It will be 2 into 1 plus 2 is gone. After that, what is bursted? 4. 4 is bursted. So 4 profit will get is 4 into 3. So 4 is gone. After that, what is bursted? 3 is bursted. So the profit will get is 3 into 1. Finally, 1 is bursted. So we'll get a profit of 1 into 1. So in this case, we are getting a total profit of 2 plus 4, 3, 12 plus 3 plus 1. 12, 15, 16, 18. So see, the order in which we are bursting the balloon, that is, here we got 30, here we are getting 18, right? So the order in which we are bursting the balloons, they are basically giving us different answer, right? Hemant is asking, how can we learn solving DP iteratively in the first go? you always have to form a recursion. Like, don't just think DP as iterative DP, recursive DP, right? DP is just you to form a recurrence relation. After that, how you are implementing, that can be different, whether you are going for a iterative way of implementing, whether you are going for a recursive way of implementing. But you always have to develop the recursive. Like, for example, for Fibonacci numbers, you have to develop this recurrence relation, that f of n is f of n minus 1 plus f of n minus 2. Then you can implement it iteratively, or you can implement it as dp of n equals to dp of n minus 1 plus n minus 2, right? Or dp of I equals to, like that. How you implement, and the implementation will be just writing this recurrence relation in a loop, right? Just writing this exact thing. So this the main challenge is forming this recurrence relation, right? So there is nothing called running DP iteratively. Iterative is just a way of implementation. How do you choose to implement, right? Okay, so we see that we are getting different answer when we are bursting in different order, right? So what do we have to find? Which order gives us the maximum profit? Which order gives us the maximum profit, right? So let's understand that. So this solution, the solution for this, I'll not go into a lot of details regarding this, but the solution for this is a extension of matrix chain multiplication. So this is basically a matrix chain multiplication variant, MCM. So you can read about matrix chain multiplication, what it is. It is pretty interesting one. And very similar to this as well, right? So it is a variant of matrix chain multiplication. What we'll do here, to understand the recursion, so the solution for this will be a dynamic programming solution. So we'll form the state. So what is f of ij, right? What is f of ij? F of ij, or we can have nm as well, whatever you prefer, right? These are just states, whatever you name them. F of ij is the maximum cost. Maximum cost we can get by bursting. Maximum cost we can get by bursting balloons from I to j, index I to j. If we are bursting, so we have this array, right? We have this array, index I to j. Let's say I is here, j is here. Index I to j, if we are bursting the balloons, what is the maximum cost that we can get by bursting the balloons from I to j? So what will be the answer for this problem? The answer for this problem will be f of 0 comma n minus 1. F of 0 comma n minus 1, basically in the entire set of balloons, if we are bursting the entire set of balloons, what is the maximum cost that we get? That is the answer to our problem. So this will be the answer to our problem, right? F of ij is what? Maximum cost we can get by bursting the balloons from I to j. We are any subarray I to j, if we are bursting the balloons, what is the maximum cost we can get? The answer to our solution problem will be f of 0 to n minus 1. That is, we are bursting all the balloons. We are bursting all the balloons. What is the maximum cost we can get, right? So this is f of ij. Let's actually find what is, how can we compute f of ij, right? Okay, let me just rub these things off. Okay, now we want to compute f of ij. That gives us the maximum cost of bursting balloons in the subarray I to j. Let's say we have the balloon I minus 1. Let's call them B. We have I minus 1th balloon. After that, we have ith balloon. We have some kth balloon in between. And we have the jth balloon. And we have j plus 1th balloon. Right? What we will do here is we'll fix which is the last balloon that will be bursted in the subarray I to j. In the subarray I to j, we are bursting all these balloons, right? All these balloons I to j are bursted. We are bursting and we are finding maximum cost. So we will be fixing which is the last balloon that will be bursting. So let's say bk is the last balloon that will be bursting. Now k can be bi. This can be the last balloon that we are bursting, or bj can be the last balloon that we are bursting, or I plus 1, I plus 2, k can be anything. So basically we are running a loop for k and we are assuming that bk is the last balloon that we are bursting. Right, bk is the last balloon that we are bursting in this subarray. So that means all other balloons have been bursted. That's why this is the last balloon. So what will be the configuration when bk is being bursted? It will be bi minus 1 will be there. Now bi to everything is gone. So only bk is there from this entire range. And after that bj plus 1 is there. So when we are bursting bk, what is it that we are getting? So this is definitely maximum over all possible k. So k I to j can be the last balloon that we are bursting in the subarray I to j. So I minus k will be in between I minus 1 and j plus 1. So what is the cost if we are bursting k now? It will be b I minus 1 into bk into bj plus 1. This will be the cost for bursting. This will be the coins that will gain by bursting the kth balloon at the end, right? But is this all the cost? We have also like bursted all the balloons from I to k minus 1, right? I to k minus 1, we have bursted all the balloons. We have also bursted all the balloons from k plus 1 to j, right? And if you see, they will always be, this is a continuous, like we are not bursting bk minus 1 when bk plus 1 is beside bk minus 1, because bk is the last balloon that we are bursting. So bk has not been burst, so definitely this will be a independent subarray. This will be a independent subarray in which we are bursting, right? So we are bursting all the balloons from I to k minus 1. So what is the maximum cost that we can get? The maximum cost will be f of I k minus 1 for bursting all the balloons in this subarray I to k minus 1. And we are also bursting k plus 1 to j. So what is the maximum cost? F of k plus 1 to j. Now we want the maximum out of them. For all possible k from I to j, k is I to j, we want the maximum one out of them. So this is the recurrence relation that we are forming. F of ij, what is the maximum cost that we get by bursting all the balloons in the subarray I to j? We are choosing the last balloon that we will be bursting in this subarray. Let's say it is k. K can be anything from I to j. So we want the maximum answer out of it. So when we are bursting any k, this is the last balloon. So that's why the configuration will be like this: b of I minus 1, bk, bj plus 1. So this is the cost that we are getting. But we have also burst all the balloons from I to k minus 1. So that will be f of I k minus 1, the maximum cost that we can get. And f of k plus 1j for the later second part. So this is the entire recursion that we get. Is this clear with everyone? Is the recursion clear with everyone? Is the recurrence relation clear with everyone? Let's write it again. F of ij is equals to max of k equals to I to j f of I k minus 1 plus f of k plus 1 to j plus b I minus 1 into bk into bj plus 1. Right? This is the recursion. Okay. So now I'll actually, Hemant, how do we find the number of states of a DP? Number of states of a DP, you have to think about it. There is no shortcut. Like, you just have to think what is the minimum. First of all, start with one state, right? And does it identify each of the conditions uniquely? No, add another state. Like, you have to identify it yourself. This comes with practice. There is no rule of thumb to identify state, or no shortcut. Now for this, I can tell you a shortcut. For this, basically it's a variant of matrix chain multiplication. So that's why we can be sure that we'll need two states for this, I and j, and then we'll run a loop for k, right? Which one will be the last one that will be eliminated, because it's a variant of matrix chain multiplication. But when we are solving matrix chain multiplication, we don't have idea about the state. So it basically comes from practice, right? It will basically come from practice. So I'll give you, Hemant, I'll give you an idea here how to think iteratively right now. This is, you have to generate up to this. Now when you are writing an iterative system, just think that when you are computing f of ij, f of I k minus 1 should be computed. F of I k minus 1 should be computed, where k is running from I to j. F of k plus 1 j should also be computed, right? These two things should be computed. So what is the direction of the loops that you want to put in? For j, just see, it depends, ij depends on I k minus 1, and k is running from I to j. So I k minus 1 is definitely calculated. Let's say k equals to m. When k becomes m, m minus 1 is already calculated. So the k loop should be running from forward to backward. right? So if I k minus 1 or j loop should also be running forward to backward, because k minus 1, like m minus 1 should be computed before m minus 1 should be computed before m for the second state j. So the j loop should be running from left to right, that is from smaller value to a larger value, that is j plus plus should happen, right? What about the I loop? There is a dependency, I here is fixed, right? So there is no problem here. Here we are actually, if ij depends on f k plus 1j, where k is greater than I. K is greater than I, right? K can be greater than I. So definitely the I loop should be running backwards so that it is computed. So that, because when we are, let's say I equals to x, we are computing for I equals to x. It depends on I equals to x plus 1. So x plus 1 should be computed before x. So the loop should be running backward. The loop should be running backward for I, right? So for the first, for I it should be running backward, for j it should be running forward. So if you have to think about iterative in this way, and otherwise you can always go for a recursive solution. It will always be safer, but I prefer writing iterative because the code becomes lesser. So you can definitely think about iterative this way. Like, what are the dependencies? The dependencies should be calculated before you are calculating for the current state. So in that way you have to order your loops, right? I'm coming to that. Just let's get this over with. So how will you solve this? Okay, first of all, dp, let's create an array of size n plus 2, right? We'll append 2 ones at the end, right? At both the ends we'll append a 1 and 1. So vector int arr, initially we'll take a different vector, arr dot pushback 1, arr dot pushback 1 for int v belongs to a. After that all the elements will be pushed, arr dot pushback v, and finally we'll also push another one. Now we'll set this entire array to be 0. So I equals to 0, I less than n plus 2, I plus plus, for int j equals to 0, j less than n plus 2, j plus plus, and dpij is 0. Okay, one more thing, just one more thing. Now the array in this arr, the array is 1 based, right? Because at first we have pushed a 1, so the elements are present in the range 1 to n. So our answer will be dp 1 to n, not 0 to n minus 1, right? Because now we are at 1 based index, so our answer will be 1 to n. So let's compute. So for int I equals to n, I greater than equal to 0, greater than equal to 1, I minus minus, for int j equals to I, j less than equal to n, j plus plus. Let's first it is 0, so let's run a loop for k. For int k equals to I, k less than equal to j, k plus plus. And what is dpij? dpij is max of dpij, dp I k minus 1, just writing the recursion of dp I k minus 1 plus dp k plus 1j plus arr k into arr I minus 1 into arr j plus 1, and finally we return dp1n, right? So let's run this. Let's see if this is working. So we are getting 60, which is expected. So let's run this. Okay, so we got we got this correct. So this is how we can solve this, right? Now Harsha has asked, how can you repeat the second question, like how did you find the pattern of the odd even? Actually there's nothing complicated, right? Like, see, you cannot swap between I and I plus 1 if only you can swap when it is even. A of I and A of I plus 1 is even. So that means either both of them, A of I plus 1 has to be odd, both of them, or both of them has to be even, right? So now let's assume we have a 1, and after that, like after some elements we have a 2. Can 2 ever cross 1? 2 can never cross 1, right? Like let's say there is a there are some elements in between. So let's think of like this, that so we have some 1 here, let's say some 1 here, between some elements are there, after that a 2 is there. Can 2 ever come to the left hand side of 1? It can never come. Why? Because you are swapping like this, you are, let's say, swapping like this. After that you will come into a situation of 1 to right, because 1 is on the left hand side, 2 is on the right hand side, so you will definitely come as 1 and 2. In that case you cannot swap between them because they are odd. So that basically tells us that if there is the odd segment and after this there is a event segment, none of the elements of the event segment can cross this odd segment. Similarly, none of the elements of the odd segment can cross this event segment, but within the same segment they can be interchanged between each other, right? They can be interchanged between each other. So that's why you can that's why that gives us the idea that, hey, if they can be arranged between each other, and they can be fully swapped between each other, right? So basically we can convert each of them to be descending, and that way we can generate the maximum lexicographic array. Does this make sense, Harsha? Okay, great. Yeah, I have recognized you actually. Cool. Anyways, any more doubts? Any more doubts? Anyone has? Otherwise, we can end the class here today. Anyone has any more doubts? Uh, you're welcome, Silva. Cool. So yeah, we'll meet on the next day. So I think tomorrow we'll have a 29-day series from Amazon. So if you guys don't know about this, I'm running a series called 29 days of preparation for Amazon. So in that case, in that we'll solve every day. We are solving around 2 problems, and I'm giving like 3-4 problems as homework every day. The idea being that by end of 29 days, you will be like done with a lot of problems. So if you are actually, and you will also get that momentum as well. So if you're interested to solve a lot of problems, you can come there. We do that every Monday, Wednesday, Friday, from 7:30 to 8:30. But again, like last week we were only able to do Monday because we had some I had some technical difficulties on Wednesday, and there were some issues on Friday, so it got cancelled as well. So yeah, from next week again we'll be doing Monday, Wednesday and Friday, right? So yeah, I'll see you guys there if you are interested in joining. Other than that, thanks for joining, and I'll be seeing you guys